Let's dive into Python's magic methods. So, what are magic methods? They are special methods in Python with double underscore on both sides, often called Dunder methods. They are powerful mechanisms that allow you to customize your object's behavior at fundamental level. With magic methods, you can control how your objects are created, represented, compared, and much more. These special methods provide hooks into Python's internal operations, allowing the custom classes to emulate built-in behavior. Some common examples include init for object creation, str for string representation, len for determining the length, add for custom addition, and eq for defining equality between objects. Magic methods are the foundation of Python's everything is an object philosophy. Let's move on to object initialization and representation. Our first key magic methods are init and repr, fundamental to creating and debugging objects. The init method controls object initialization. It's called whenever you create a new instance of the class, which is where you define the object's initial state and setup and any required attributes. Meanwhile, the repr method provides a detailed representation of your object, primarily intended for debugging and development. It should be ideally return a string that, if evaluated, would recreate the object. In the example, we have created a book class with both methods. When we instantiate a book with title and author, the init method stores the attributes. Then, when we print the book object, the Python automatically calls repr, giving us a clear string representation showing exactly what this book instance contains. This makes the debugging significantly easier. Next, comparison magic methods. They are the powerful tools for defining how your objects relate to each other. Methods like EQ, LT, and GT allows you to customize equality and ordering relationships between the objects. With these methods, you can override default behaviors and implement domain-specific comparison logic. In our product class example, we have implemented the EQ to define that two products are equal if they have the same price. We have also implemented LT to compare products based on their prices, allowing us to determine if one product is less expensive than other. This means that we can now directly compare both product instances using the familiar syntax like double equal to or less than, and Python will use our custom comparison logic. Behind the scene, when you write product 1 equal to product 2, Python actually calls the product 1 dot eq of product 2. These methods are particularly useful for sorting collections of custom objects or implementing the business specific comparison rules in your application. And finally, container magic methods. They are the secret to creating custom collections like objects. Methods like len, getItem, and iter allows your class to behave like Python's built-in containers such as lists and dictionaries. They enable custom length calculations, index-based access, and iteration functionality. In our custom list example, we have implemented len to return the length of our initial storage and getItem to provide access to items at specific indices. These methods allow our custom class to respond to built-in functions like len and support indexing with the square bracket notation. This pattern is incredibly powerful for creating domain-specific collections and data structures that integrate seamlessly with Python ecosystem.